This is a lecture video for chapter 7, section 7.1. So in chapter 7, we are going to talking about applications of trigonometry, and later on in the later section we're going to talking about vectors. So the first section, section 7.1, we're going to talking about oblique triangles, and then importantly law of sine. And in the law of sine, we are actually going to do two sections, 7.1 and 7.2. 7.3, we're going to talking about law of cosine. So for section 7.1, there are going to be 5 videos. This is the first one. In the first video, we're going to review the properties of triangles. The first property we're going to review is the angle sum of a triangle. So this property says the sum of the measures of all the angles in the triangle is going to be 180. So for example, if I have a right triangle, one of the angle is going to be 90 degree. And then the other one, for example, if I have a 60 degree, then the other one is going to be 30. If I have another right triangle, and then one is 45, then the third angle is also going to be 45. This is also a isosceles triangle. Okay, we can have also other weird angle measurements. Like for example, I have one of the angle is 45, the other one is 61. Then according to the all the angle sum is 180, I know the third one is going to be 71 degree. The second property we're going to talk about is the triangle side length restriction. So in any triangle, the sum of the length of any two sides must be greater than the length of the remaining side. So what that means is if I have 3 sides, like the first one is 3 inches, the second one is 4 inches, the third one is about like 10 inches. Then using those three sides, I cannot form any triangle. So for example, I have a 10 feet one on the bottom, and then I have a 3 and then a 4 centimeter one on the other side. So because of the 3 plus 4 is smaller than 10, according to this restriction, I cannot really form any triangle from it. The last property we're going to review is the similar triangle. So what is a similar triangle? For example, I have 2 triangles. So the first one, I have a leg size of 2 and 2, and then a hypotenuse. So 2, 2. The hypotenuse, I'm not going to calculate it, and then I cannot really read it from the graphing paper. And then I'm going to make it larger by extending the side, the 2 and 2 side, make it twice. So I'm going to make it like a 4. So this one I have a leg size of 4 and 4. So you can see these 2 triangles are a similar triangle. The only difference is one is smaller, one is bigger. And by how much? By 2. So because I'm using the graphing paper, so just to taking the advantage of a graphing paper, both of my triangles are right triangles. I have a 90. And then because I have isosceles triangles, the sides are 45 degree and then 45 degree. Okay, so we're also talking about the conditions of similar triangles. So if I have 2 triangles, ABC and DEF, for example, ABC, this is my labeling, and then DEF. Then if the two triangles are similar triangle, that tells me the corresponding angles must be the same measurement. So for me, the corresponding ones as B is corresponding to the angle E. So those two are the same angle, 90 degree. A is corresponding to angle D. They are the same measurements, 45. And then C is corresponding to angle F. They are 45 also. And also talking about the corresponding side are proportional. Since we have B and E are the right triangles, then you can see that the side AB and then the side DE are the corresponding side. The side BC and the side EF are the corresponding side. The two hypotenuse are the corresponding side. So without calculating the hypotenuse, what we know is the side AB is 2 and the side DE is 4. If I'm talking about the proportions of AB and DE is 1/2. Then if I'm talking about the other corresponding side, BC is 2, EF is 4, then BC over EF, the ratio between those two is also 1/2. So the second condition said the corresponding side are proportional. That means the ratios between any corresponding two sides are equal. So both equal to the ratio of 1/2. So I make it twice as much bigger. So another term when we're talking about triangles is the congruent triangle. Congruent triangle is more stronger than similar triangle. Similar triangle says I have two triangles. They are similar. Maybe one is a smaller size, the other one is more jumbo size. Congruent triangle is talking about I have two exactly the same triangle. They might be placed in a different rotation, but they actually the same triangles. Same measurement on the angle, same measurement on the length. So when we're talking about congruent triangles, it's really hard to check every single leg and every single angle. So we have the following 3 methods to check if two triangles are congruent or not. The first one we have is called the side angle side, or SAS. So this one talking about if I have two triangles, no matter how I place them. And then if I know there are two sides. So one of the side they have the same measurement, and then there's another pair of side they have the same measurement. And also remember we're talking about side angle side. The angle between those two sides also have the same measurement. Then we know those two angles are congruent triangle. They are exactly the same triangle, just different rotation. The second method is called the angle side angle, or ASA. So if I have two triangles, and then I know that there are two angles are the same values. For example, the two on the top and then the two on the bottom, they have the same measurements respectively. Then remember the name said angle side angle. The side between those two angles also have the same measurement. That tells me those two triangles are a congruent triangle. Those two angles are exactly the same. The third one is side, 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 or SSS. So this one is very straightforward. I have two triangles. No matter how I place them, I know the three sides are the same between those two triangles. I do not need to check any of the angles, and I can conclude those two triangles are congruent triangle. Those two triangles are actually exactly the same triangle. However, we do not have anything like a AAA, angle, or SSA, side-side angle, or any other combinations. So we only have those three situations. And those three we're going to use to develop the law of sine formula and then the law of cosine formula for the later.